So hello again. Another lecture from me today. And today's talk is going to be basically some of the notes that I gave. I was invited to give a keynote at the University of Maine in 2021, talking about surveillance technologies. And at first you might say, well, why are we hearing about surveillance technology in a class about AI images? Well, the answer to that question is that a lot of the data sets that we are using to create images are collected initially for other purposes. If you want to generate a image of a butterfly, then perhaps the butterflies you're generating are being taken from a researcher's archive of butterfly scans, right? And this can be the case that you have a bunch of images collected for one purpose that is shared for research purposes with other organizations or institutions. But once that data set is out there, anyone can use it for any purpose. And so one of the things that is a very interesting and fraught relationship in the world of artificial intelligence and images is the fact that so many of our data sets exist not necessarily because of a desire to create tools for making new pictures, but because we wanted to build other things like facial recognition software, handwriting recognition software. There is a lot of data that is out there that was produced for one purpose that's being used in the models that we're using that are tied to other purposes. And we're going to talk through some of that in this talk. So I hope you'll understand that the reason we're talking about surveillance is so that you can understand some of the ways that this pipeline works, that the data that we're using to generate the image of a face is tied to other uses, not just here, but around the world. And those other uses are a possible avenue of critique and commentary that we can reflect on when we make these images or choose how to make images or choose not to make these images. So I'm going to lay out some of the background of technology and surveillance. This was originally sort of framed in the context of George Orwell's book, 1984. Now, if you haven't read 1984, that's fine. Most of this stuff is going to be self-explanatory. But 1984 is a kind of dystopian world, right? The book was written in the 40s by George Orwell. And it talks about this dystopian world where surveillance is kind of everywhere. It's hidden in television sets. And there's a big shift in the way that Orwell's generation saw surveillance and the reality that we are living in now that has kind of normalized what might have been terrifying to someone like George Orwell. So bear with me. I hope you consider this talk in that context. There are direct ties in this talk to the way we make images. So yeah, all right. Without further ado, I'm going to share some slides and we can start the talk. So to start, I would just want to set the stage that the first time I read 1984 was 1986, and it was actually the first novel I'd ever read. This is because my grandfather had it lying around his house, and when I picked it up, I ended up being swept into a world of politics, torture, and propaganda that has kind of stuck with me for the rest of my life. And I credit that to the sheer force of George Orwell's writing, but also because this particular book would be a pretty big trauma to any first grader who's never read a real book before, which is the situation that I was in. And this year, actually, 1984 is old enough to be in the public domain. So if you wanted to go out and publish your own edition, you could. But I think you'd probably find it a challenge to modernize it. There's a lot of adaptations over the years, and all of these adaptations seem like they are creating new varieties of the technologies that Orwell described, but they all more or less stay the same. These technologies play a larger role in Big Brother's omniscience, but the thrust of Orwell's argument is not about what technology is, but the ways that we use it. The telescreens people watch in that book are also watching people, and later that's not that different from the way that we're communicating literally right now. There's nothing fancy in Orwell's book. There's no robot super soldiers. There's no talking cars, no hovering police drones. The technology of surveillance in 1984 isn't the result of smaller circuit boards or smarter artificial intelligence systems. Instead, the future is wrapped up in ideas about what the limits on surveillance could be and how omniscient it could become. Orwell's world is dystopian. It's a totalitarian state where surveillance is not just conducted outside of you, but it inspires its citizens to surveil inside of themselves. Orwell imagined telescreens in every home broadcasting propaganda, but also serving as a two-way mirror to monitor those who watched. There were windows into the prison cell, but the cells were where we lived. Orwell's vision was a nationwide upgrade of a system that was designed for prisons by the philosopher and social scientist Jeremy Bentham in the 18th century. This is called the panopticon. Now, I don't want to get in trouble here, but if you are watching this on the website as students, you're watching this through something called panopto video. And this video is tracking the way that you're watching it, and it's conveying that information to me. So something to think about. Here, this panopticon is quite simple, the one that Jeremy Bentham presents that I'm sharing on the screen. And it's still used in the design of prisons today. It's a central tower with opaque windows, and it's surrounded by a circle, or like a pentagon, of cells. And this design meant that the guard could look out from any window of this tower in the center and see every prisoner. And the prisoners, on the other hand, they never knew when the guard was looking at them. They couldn't see the guard. So because they didn't know when the guard was looking at them, they behaved as though the guard was always looking at them. This self-imposed sort of imprisonment meant that one guard could keep tabs on an entire building or a full wing of prisoners. The floor plans of prisons look like child's drawings of flowers or suns. Here you see 6 different panopticons with a church steeple at the center, suggesting the eye of God, right? This was meant to, literally, to suggest the eye of God watching the prisoners as well. For Bentham, this was a humane improvement over prisons because it showed that you could exert power without torturing people, without beating them, but you could exert psychological control on those prisoners. Orwell, in his book, replaced this idea of the prison tower with screens. The TV screens came on and they blared propaganda, and it allowed basically for this 1948 version of video conferencing. But in his book, Television Watches You, Orwell wrote, well, let me get that quote. Orwell wrote that there was, of course, no way of knowing whether you were being watched at any given moment. You had to live in the assumption that every sound you made was overheard, and, except in darkness, every movement scrutinized. This is from Orwell's book, 1984. And because these citizens of Oceania, the country that Orwell describes, had no idea when Big Brother was watching them, they behaved as though Big Brother was always watching them. Now, this does not seem to horrify us the way it horrified Orwell back in 1948. And I started to realize this sometime in 2010, when I started seeing my friends update on Facebook about locations they were visiting. And so is the mayor of McDonald's, I would see. And this was an app at the time called Foursquare. Foursquare let you tell your friends where you were using geopositioning, and also told them how often you had been there. And soon after came Instagram and its instant, endless stream of location data and food photos told me not just where my friends were, but what they were eating. And along with these technologies emerged this surveillance economy, all tied together into the hottest commodity of the 2010s, big data. Big data is a byproduct of your digital transactions. If you swipe a credit card or place an order on Amazon or any other digital retailer, it's going to keep records of what you've purchased. It links those records to your name and your email address. And this information is cross-referenced with grocery store purchases or gas fill-ups that you might make in person. The idea of big data is to anticipate your purchases, make personal suggestions and recommendations. Netflix can tell you what to watch. Amazon can tell you what you might want to read. Spotify or Tidal can tell you what you want to listen to. And Tinder can tell you who you might want to date. Google might tell you which website you want to look at. And Facebook can do all of this stuff, more or less. And somehow, being observed and directed all the time doesn't seem to horrify any of us the way it terrified people back in Orwell's day. Instead, we're thrilled with the convenience. Or to be less judgy about it, I'm thrilled by the convenience. I love finding new music. I met my partner through a dating website. And I wouldn't be the first person to suggest that the sheer volume of data that's generated about ourselves and everybody else on the planet has lulled us into a sense of security. We thought we had control over who saw our data and when we shared it, forgetting that the apps are tracking us either way, right? You might opt in and say, oh, don't share this data, but there's some information that's probably getting out there. We feel that with so much data out there on so many people, that there's probably no way that anybody is watching it. And that certainly nobody's watching little old me. And if you're reading this on your home telescreen, websites and telecoms are gathering your data. They'll know how long you read. They'll know how much of this video you've watched, how much you've skipped. I will see this, right, as your instructor. Might even see what you've typed to your friends in the chat window. If not me, then maybe someone else is able to track that information. But you're probably comforted by the fact that nobody's ever going to look at that because there's just so much of it, right? Or if you do, you're going to be this anonymous blip on a data spreadsheet. And I just want to say, nonetheless, this is surveillance. And I want to ask you where you personally draw the line. Following this idea of George Orwell's slogans, war is peace, freedom is slavery, I want to add this third one, surveillance is anonymity. Of course, these are all dystopian slogans, right? Where Orwell is saying the big brother is telling us the opposite of the way we understand things. The opposite of that understanding is actually what's true. This is what the propaganda is telling us. And I would say the idea that there is so much surveillance that we are anonymous suggests this kind of relationship. So a couple examples. Last year, Microsoft acknowledged that contract workers in China had access to your Skype calls, and they could listen to them in their homes in order to work on improving voice recognition software. So here's an artificial intelligence tool that needs human training, and humans, in order to train this AI tool, are able to listen to your Skype calls. They didn't know your name, but they heard your voice. They knew how you spoke. They knew what you spoke about. Is that something you're comfortable with? Even though they don't know you, it's a stranger, right? But they don't know what you're talking about or what your name is, but they can hear parts of your conversation. They can hear words that you're saying. Siri, Alexa, and Google had similar practices in place. Facebook has access to pretty much anything you've ever written, including DMs on the platform. And for whatever reason, they've been purchasing data on women's menstruation cycles as women have entered this information into health apps. Is that something you're comfortable with? It's abstracted. It's not your name associated to this information, but it is your information, and you've entered it into an app, And that app has this information, and now they can sell it to other companies. They can sell it to other apps. They can sell it to marketing companies, right? And they can tie it to this key, this token that represents you and the purchases you make and the websites you sign up for, et cetera, et cetera. So I would argue that the age of Big Brother is now the age of big data. And we've moved from an interest in monitoring the behavior of citizens to monetizing the behavior of citizens. So it's easy to see that the majority of people don't really care about this stuff, or at least maybe they don't know about it. But perhaps it's because we've all made this unconscious bargain. We trade our privacy for information about ourselves and the conveniences that we get from these algorithms. But I want to think through some of the connections here, to think about what Orwell might make of this hands-off attitude to the stuff of our lives. Orwell was explicit about the role of Big Brother. Its citizens behaved as if someone was always watching them. But our thinking about big data is the inverse. If everyone is always being watched by machines, if everyone's data is sitting in a massive repository of hard drives somewhere in California, then nobody's being watched at all. And I want to frame that for what it is, which is actually Orwellian. This idea that war is peace, that freedom is slavery, again, leads us to maybe the same sort of construction that surveillance somehow becomes anonymity. When we went through the history of AI, we've mentioned that the word computer has had different meanings over the years. And in 1948, when Orwell was writing this book, computers were people. They did arduous math with slide rules for practical purposes. And the first American weather computer was actually created in the 1870s. It was an office full of women who took weather reports in and crunched numbers in 2-hour bursts and then sent information across a signal service using telegraph machines. So Orwell talks about these windowless buildings full of vast bureaucracies, people sorting through data, editing data, erasing data about people. And it's not too bold to say that some of the institutions in these books were what we would have considered computers back in that time. And we also mentioned cybernetics. The year that Orwell was writing, 1984, is the year that Norbert Wiener wrote this book, Cybernetics, Command and Control in the Animal and the Machine. Command and control have scary connotations, especially as we're talking about Orwell, but Wiener was interested in the idea of automation, while his writing is still marked with a deep skepticism and fear of its consequences. He's notable for writing about it with tremendous pessimism. And in the book that he wrote to popularize cybernetics, he added a warning. When human atoms are knit into an organization in which they are used not in their full right as responsible human beings, but as cogs and levers and rods, it matters little that their raw material is flesh and blood. What is used as an element in a machine is in fact an element in the machine. So in other words, what he's saying is we are human beings, but if we become basically systems for navigating mechanics of a bigger system, and we are viewed this way and come to think of ourselves this way, then really we're just pieces of a machine as opposed to human beings. And Norbert Wiener was very frightened of that reality, of that possibility. Wiener and Orwell were both concerned with communication and control, and they were both pretty pessimistic. Wiener saw the development of automated industrial technologies that eventually came to pass in his own lifetime, things like robotic assembly lines. And this fear of computer surveillance made its way into culture in other ways. In 1965, the French filmmaker Jean-Luc Godard, who passed away this year, made a film called Alphaville, in which Big Brother is reimagined as a computer system called Alpha 60. In that film, Godard imagines a future where all human bureaucracy is handed over to a computer system, and humans hand over all faith to its decisions and pronouncements, regardless of whether they understand them, answering questions with a shrug and the expression, "Never ask why, only say because." And that line sums up a history of building artificial intelligence systems. In the early days, automation was pretty simple. If a human worker had a series of steps to complete to produce an object on an assembly line, you could create a program that could imitate all of those repetitive motions. And that's what a computer program is, a series of steps that open up a different series of steps to achieve some goal. In the late 70s and 80s, automation started aiming to automate human decision-making in a machine to accomplish more complex tasks. Sorting out how humans made these decisions was left to computer programmers rather than social scientists, psychologists, or anthropologists. These programmers would never have to figure out what decisions people made. These programmers would only have to figure out what decisions people made rather than why they made them. They only basically said, they never asked why, they only said because. Just like Goddard warned us about. And in effect, you could send the computer program into any existing bureaucracy to look at those decisions being made by those workers, and then build a model to replicate those decisions the way you would build a robot to repeat the construction of car parts. The aim was to remove the human element of human knowledge and make it consistent, repeatable, and replicable. Machines would remove the messy, emotional, and relational approach that human beings have when making decisions and focus on making the same decision for every applicable purpose. Gone would be the imbalances of emotions, and soon mankind would enter the world of objective neutrality, cold and hard like facts. Skipping ahead here, sorry. If you believe that someone stealing a piece of chocolate for a starving child deserves less punishment than someone stealing a piece of chocolate from a hungry child, then you can begin to imagine how this one-size-fits-all approach might start to fail us when we start applying it to very complex social and philosophical and ethical dilemmas. There are endless exceptions to situations, and there's exceptions to the exceptions. Human decisions are pretty irrational at times. They're swayed by emotion. They can lack objectivity. That doesn't mean that computer-driven systems are inherently rational, objective, or fair. And even if they were, that doesn't necessarily mean that they're desirable. Nonetheless, much of the industry that's out there still believes that the opposite of an emotional decision is a fair decision. And that's a value that gets encoded into the systems that we see being built. Artificial intelligence systems don't make decisions on their own, and they never will. I suggest they never will. Humans are going to tell them what to do, and humans are going to build them in order to do something. Humans are going to set those priorities. Humans are going to program them to serve our will in a world that we explain to them. The problem is that the language we use to describe our world is constrained to the logic that computers can understand. When we have to code the world into the constraints of computer memory or programs, the complexity of the world gets reduced. When I read the segments of Orwell about language, my mind goes towards this. 1984 comes with an appendix on newspeak, the language used by the party in control to limit and reduce people's thinking. And it has some parallels to the way that we have to describe the world to a computer. Orwell writes about a series of vocabularies and names the most basic set of words the A vocabulary. Now, we can think about this as the way that we categorize images, too. We talked about image categorization. How do we decide when something is an apple, an orange, a puppy, a cat? When do we understand someone as a person versus a job? How do we decide someone's gender or race by looking at them and a single photograph, right? So here Orwell is talking about the A vocabulary, and he says it was composed almost entirely of words we already possess. Words like hit, run, dog, tree, sugar, house, field. But in comparison with the present-day English vocabulary, its number was extremely small, and their meanings were far more rigidly defined. All ambiguities and shades of meaning had been purged out of them. Newspeak words were simply a staccato sound expressing one clearly understood concept. So think about this as the way we describe a picture to a computer when we assign it a tag or a category. And think about what this means in terms of the way that the AI can visualize the world and what it can tell us about that world when we ask it something through a prompt. Newspeak also had a binary. The word for cold existed, but the word warm did not. So it was replaced by its opposite, unwarm. And if you spend time in computing, you could see some parallels, right? Computers need concrete, explicit categories. Something needs to be on or off. And they are not going to necessarily make a guess. If you've ever tried to program something in code, the computer is not going to say, oh, I think you're trying to get to this result. Here's how you might do that. Increasingly, we're getting better with AI at doing that, actually, because we have these examples. But it can drive you pretty crazy if you're trying to write software, or you're trying to write code, and you just can't figure out what your error is, and there's no way to ask it. A lot of people assume that this demand for explicit instructions means that computers can't be influenced by culture, that they're rational observers and logisticians, but the opposite is true. For a computer to act or make a decision or predict or execute a code, a human had to sort the world into small boxes of categories. That process is entirely the product of human decision-making, so it reflects some human biases, assumptions, and ideas. When we talk about algorithmic bias, computer bias, this is the type of stuff we mean. Humans are making decisions about what the code is doing, and there's a lot to say about how we explain the world that we see to a computer so that the computer can make those decisions. And that is a human being making decisions based on their own expertise, their own values, their own ideas about how the world works. And in the end, you're reducing ecological, social, and emotional complexity into as few lines of text as possible, or into the names of specific folders containing images. This is practical for the sorting of books or for an assembly line that can manufacture car parts, but it's less helpful when we attempt to impose strict categories on human behavior and society and culture. Because when someone starts to carve complexity out of the world, someone's making decisions about what they want to include, and they're making decisions about what they want to leave out. Those decisions end up being inscribed into a mechanical process that we then can't see. We can't have, we don't really understand what it's doing, right? We don't know the output of an AI model all the time. We don't know what decisions the AI is making, but we've inscribed something into that model, into that algorithm, based on our understanding, based on the programmer's understanding of how the world works. And then once this algorithm is in place, it's likely to just keep on repeating this process, this understanding. In 1958, Hannah Arendt wrote that the translation of our world into the symbolic logic of machines could create a loss of power for human speech. That once we translate things into these mathematical formulas for machines, we might not understand what it was that we translated in the first place that the machine is acting on. So if we don't understand the positions and personal experiences that shape the way computers understand the categories we give them, then we're handing the task of defining rules and making sense of the world over to these machines. And they're going to follow laws that only computer programmers get to write, and they're going to make decisions we can't explain, but have to trust, or inherently trust anyway, because we think that they're objective. And so one of these questions that we might ask is, what are the systems we're building, and why are we building these systems? And this is where we start talking about surveillance systems. There's a system deployed throughout the United States, automated face recognition software. And today, cities around America are using artificial intelligence to identify people who have been accused of crimes. To create an artificial intelligence technology that can identify human faces, here's what you have to do. Here you see Abe Lincoln in an image classification series. The image is first broken down into shades or colors, right? So Abe Lincoln's photo is broken down into this sort of gradient that you see on the far left. And these colors match an index of numerical values. This is what you see in the middle. This is a value assigned to that color, to that shade that the computer has identified. So it's reduced the world quite a bit, right? We've taken an image of Abraham Lincoln. We've already reduced it once into this very high contrast, highly pixelated kind of block world. Those blocks are then understood as pieces of a color library. They're assigned this code that corresponds to that shade of black and white and gray. And of course, you could do this with color too, right? We're simplifying this. And then what happens is those numbers themselves are stripped and isolated as numerical data. And this series of numbers is essentially what the computer understands as an image. So we see a picture of Abraham Lincoln. The computer sees 157, 153, 174, 168, 150, 152, and so on. Now, I want you to take a look at where the eyes are in this image of Abraham Lincoln in this middle piece. You see a certain cluster, 209, 185, 215, 84, 10, 168, and so on, right? So this 10 on the left eye of the second picture. Now, what happens with image recognition is that it's saying, okay, vaguely, if I understand 209, 185, 215, 84, 10, 168, etc., tend to cluster together, then when I encounter part of this sequence, 209, 185 with an 84 underneath it, I'm going to say maybe this bottom quadrant is a 10, because that's something the machine can predict. It's looking at this set of numbers on the right, and it's saying these are patterns, and pieces of this pattern appear consistently in an image. And if I see this row of patterns, this 209, 185, 215, 84, 10, I'm going to say that's an eye. And if that's an eye, then I could figure that maybe 2 pixels away is the other eye, right? Maybe a couple pixels away is an ear, etc. Especially if it knows where the hair is, right? Because it's not just doing this for eyes, it's doing this for noses, it's doing this for mouths. But you see what's happening here is that the image that comes into the computer is translated into color codes. The color codes are written basically as text and analyzed as patterns. And then when it encounters pieces of that pattern, it says, okay, I think I know what this is. It's an eye. Now, we used to have to manually tell the computer the clusters in the center are a nose, and that just above that to the side of your ear were your ears, right? And basically what's happened, as we saw, is a bunch of people saw these pictures and identified pieces of these pictures, and the computer had a training data set and was able to learn how to figure this out. And once it did, it got more information, and it got better at recognizing these patterns. Likewise, as data got more refined, the pixels, these giant pixels by relative standards that you see here today, became smaller and smaller and smaller. And so you got much more detail, right? Millions, maybe not millions of pixels, but many, 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 many pixels might define an eye, okay? And then it gets even better at understanding those patterns because it's better at processing data. It's better at processing information and patterns because the algorithms have been more refined and sharpened. So for our discussion today, the gathering and analysis of data for an artificial intelligence system is basically called training the artificial intelligence system. That's humans gathering and analyzing data for the AI in order to tell the AI what to look for. That's called training. The mathematical rules used to identify those patterns is typically referred to as the algorithm. Once you train enough data, the algorithm can keep learning based on what it has learned before and identify more patterns that fit its algorithm, and it can adapt that algorithm. It can change that algorithm based on new information that it's encountered. Algorithms are often used to make predictions. You might have a weather algorithm that tells you when it will rain. You might have a music algorithm that suggests a song you might like. Amazon has an algorithm that tells you what books you might want to purchase. This is all done in very similar ways. And it's worth thinking about that that this is not isolated from the images that we want to make, from the AI that makes an image and the AI that tells you what you might want to watch on Netflix. There's a lot of overlap in the way these systems work. Facial recognition systems are largely built from images that programmers pulled from the World Wide Web. And one of the largest and most used models came from portraits of people posted to the website Flickr. That's a data set. Instead of writing code that describes every possible face, today's neural nets can study these images, thousands and thousands of images, find patterns between them, and predict things. So, for example, one model was trained to produce a random face whenever we wanted one. Now, this works the same way. If you can look at an image and understand an image coming in as Abraham Lincoln, because this cluster of pixels is an eye, then of course you could say, give me a picture of an eye, and it could say, okay, these are the pixels that I have identified, I being the algorithm, which is not a thinking entity. It's something that the algorithm has identified as a series of pixels that represents the classification that it has come to learn as an eye, or a mouth, or a nose. These images are people who do not exist. And this was another big breakthrough in GANs, generative adversarial networks. And we're going to go deeper into GANs next week. But these are two photographs of people who do not exist. They are portraits made from a machine learning model that was trained on 70,000 images taken from Flickr, taken from anyone who posted a picture of themselves to Flickr or a picture of someone else to Flickr. And the model learned it, and it was asked to create something that followed the same rules. In 10 seconds, you could create literally hundreds of these pictures. And it began identifying patterns common to all these images and quickly sorted out, and eyeballs here, mouth is here, et cetera, et cetera. When a surveillance camera sees a person in a parking lot that maybe doesn't belong there, an artificial intelligence tool can use this same learning to identify and match aspects of a real face to an archive of images in a criminal database, or a license database, or passport database. In other words, the camera that's in a parking lot will see a face, and it will figure out if this is the eye, then the other eye's over here, and this is the nose, and this is the mouth, and these are the ears, and this is the hair, and this is the style of hair, and so on. Once it has that, it can figure out the other clusters around those things that it knows, and it can then go and scan into an image database, for example, the FBI's image database, or a passport database, or your license database, and it can find matches in the patterns of your license photo, passport photo, et cetera, and the image that has been captured by the camera. And the image that has been captured by the camera can then say, this is so on, this is this person. The photograph of this guy hanging out in the parking lot is Eric Salvaggio, right? That's me. If I were creeping around a parking lot and the images it gathered were my face, it could find my eyes, my nose, and it would say with a high likelihood that this is Eric Salvaggio. Now, if it's a person who looks like me, what happens then? Well, what happens is it generates a bunch of people who I might be. And this image is then sorted through, and this could be any number of photographs who look like guy with glasses and eyes and a beard, right, with a swoopy haircut. That's, again, this is me. The FBI has a photo archive of 640 million faces, and these are drawn from state driver's license data, and they can compare this to images of grainy footage of parking lots. And we can start the process of sorting and categorizing the photograph in the surveillance image and the photographs in this database until it has a match. It will see the center of your face has a nose, compare that to the nose, and the ratio of your nose to your eyes, and this kind of thing, to what's in the existing database. Okay? Then it can identify you or a group of people who look like you and compare it to a criminal database, or just driver's license, like I said, and pass that information on to local agencies interested in knowing who it was in the parking lot at that time. So only after these systems were deployed in various cities around the world did anyone stop to look at the data that these systems were trained on, those 70,000 pictures downloaded from Flickr. And they only started looking because these systems were constantly getting Black, Asian, and Native American faces wrong. Even with technology built for innocent purposes, like Face ID for turning your phone on, wasn't working for folks with darker skin. The same systems were already deployed in less than innocent contexts, such as police surveillance systems. And by innocent here, I mean risky, right? In these surveillance systems, Black men in particular were 100 times more likely to be mistakenly identified than the faces of white men. And I want to be really clear about what that means. What it means is not that if you were a Black man in a parking lot, that you were getting away with it, that you were getting away with crimes. What was happening is, if the machine saw a Black man in a parking lot, it was more likely to link it to someone else, to misidentify the person, which would then lead to that person getting accused or questioned or interrogated or whatnot. How did this happen? Well, I will tell you my own experience is that I looked at the data set being used to train these programs. I looked at the Flickr data set of 70,000 images, and I couldn't look through all of them, but I took giant samples of them, and I looked through all of them. This is part of my own research project. And it quickly became clear that the images that were being used in this Flickr database were not representative of every racial demographic in America. Instead, these systems being trained to recognize one category. They were being trained to recognize one category of human being, which is human beings who use Flickr to share photographs of themselves or other people. And when I went and I looked at the sampling of 70,000 images of faces that were used to train this image recognition model, I found that the faces in the archive were mostly white faces. Only 3% of the faces were Black women, whereas nearly 30% of the faces were white women. So the program became very good at recognizing white faces and very bad at identifying Black faces. This claim has been verified repeatedly through other researchers, most notably by Joy Buolamwini at MIT and Deb Raji at Mozilla, whose research work, alongside the many activist groups and grassroots organizations, encouraged IBM and Google to look at their systems. And IBM and Google actually looked and said, you're right, there's problems here. We're going to pause our surveillance system development. And yet, many engineers at smaller security firms and startups would continue this work of designing face recognition software using flawed data sets without looking to see if there were broad racial disparities in them, despite knowing the false arrest and imprisonment rates of Black men in the United States. And in 2019, the General Accounting Office noticed that the FBI had absolutely no steps in place to test the accuracy of facial recognition software. There were very few laws on the books mandating audits of these systems or restricting the ways that they were used. Now, another case in point is the Chinese government's use of facial recognition systems to recognize members of the minority Uyghur population. And this software would literally be used to send an alarm when Uyghurs were recognized. It was essentially a program designed for the surveillance of a minority group in China that has been regularly detained, with the UN reporting that more than 1 million arrests of Uyghurs has occurred in China under vague and spurious legal charges. So it doesn't stop with face recognition. Another example of this logic is crime prediction technology, which shockingly is a thing. Every once in a while, a state or a country gets the idea that you can predict whether someone's going to commit a crime. A system that looks at arrest rates in certain neighborhoods, for example, would then send more police cars to those neighborhoods. And when you send most of your police cars to one neighborhood, then most of your arrests are going to take place in that neighborhood. So this system kept assigning police to patrol a neighborhood, which would drive up the number of police in the area, who would then notice more crimes in this neighborhood, would arrest more people in this neighborhood, which would then cause the system to send more police to this neighborhood, who would then notice more crimes in this neighborhood. And it kept leading to more police being assigned to that neighborhood, driving up arrests. This is called a reinforcing feedback loop. Now, you might say, well, all these crimes are happening in that neighborhood, maybe the police should be there. But what's missing is that there are other crimes that may be taking place that are going unobserved. You remember when we talked about this idea that there's a reality and then there's the data about that reality? This is what we're getting at. This is why it's important to make that distinction. If you act solely on the data, you don't always understand what you're acting on. You're acting on what has been measured, not necessarily what is happening. And this was a fundamental flaw in some of these predictive crime prediction software technologies. That algorithm, let's think about this. That algorithm feeds into other algorithmic systems that are not necessarily run by computers, but could be. And some of them are. So imagine a community using software to predict repeat offenses, and then using that to determine bail. There was such a software. The software was shown to consistently suggest higher bail rates for Black defendants because it was trained on data that suggested Black men were more often rearrested. And an example of this was that last year, the Washington Post ran a story on Niger Parks, a Black man whose face was recognized at the scene of a crime, even though witnesses placed him 30 miles away. Niger had a 10-year-old arrest record. I think he had been caught with marijuana 10 years prior. And this arrest was still in the database. So when police ran a photo of the actual image of the scene, the surveillance system did what these systems are trained to do. It looked at his nose, it looked at his eyes, it looked at his ears and hair, and it looked for the closest match in the crime database. And it ended up falsely pegging Niger Parks as the suspect. And police went and arrested him. And while he was in the system, another algorithm recommended that he would be a flight risk, that he would leave the city if he was released on bail. This algorithmic system saw that he had a past criminal record, 10 years old, and said, well, you know, don't let him go. Now, one of the things that's especially crazy about this case is that Niger Parks almost pleaded guilty to the crime. And let's be clear, Niger Parks was 30 miles away from the scene of the crime. Niger Parks knew he did not commit this crime. And yet, he was going to admit that he had committed this crime because the police had algorithmic evidence of facial recognition technology that said, yes, you were there. They had algorithmic evidence suggesting this person is a flight risk because of his past criminal record. And essentially, the computers had dug up so much evidence saying that he was guilty that he had to almost acknowledge it himself. If he had pleaded innocence and a judge had sided with the computer, he would have had a mandatory 10-year sentence. Now, luckily, lawyers intervened and Niger avoided incarceration, but this is not the only example of the phenomenon. There are countless others around the country and the world. George Orwell, to go back to George Orwell, he wrote a lot about thought crime, this idea of being arrested by the state based on its prediction of what your thoughts were and what you were thinking about, and whether that was harmful to state interests. And I can think of no better example of technology that enacts this prediction online with thought crime than this. In Orwell's Brutal Part 3, Winston, the protagonist of the story, is repeatedly forced to deny the evidence of his own eyes and ears, to say that whatever the party says is true. Winston is in a prison cell, and he's being forced to acknowledge that as a torturer holds up 2 fingers, that it's actually 3. And Winston knows that it's 2, but he knows that he must come to accept that if the state tells him it is 3, he needs to say that it is 3. And not only that he needs to say it, but he needs to believe it. Now, I am not comparing America to Orwellian thought crime dystopia, right? But I am suggesting that these systems set out a framework where that type of situation came very close to being reality. That Niger Parks looked at the evidence that was being presented to him by a series of machines and was forced to say what he knew was not true, and acknowledge falsely that he was the perpetrator of a crime. So I want to sit with that. Here is a scene from Alphaville, Jean-Luc Godard's film that I mentioned, in which people have become slaves to probability. Very similar to Orwell's world. Humans have a tendency to trust the outcome of a machine as if it were more objective than that of a human being. They feel less personally responsible for decisions when a computer makes them. If they can follow the orders of the machine, they feel like they are doing the right thing, and that if the machine says that something is true, they may as well go along with it, because if it turns out not to be true, then they're accountable for going against the machine. But if it is true, then everything's fine, right? So think about if a computer says that you need to do a certain thing, and you say, I don't actually need to do that thing, and then you don't do it, and later you get in trouble for not doing it. You would have to say, oh yeah, I know the computer told me that I should do that, but I didn't, because I didn't think I should. Right? This doesn't read the same way as someone saying, oh yeah, I shouldn't have done that, but the computer said that I should do it, so I did. This is an important thing to think about. And I want to talk about this when we talk about algorithms and artificial intelligence, and the machine scraped all this data from the World Wide Web and now it's in the model and we couldn't do anything about that. I want to think about this, right? And I also want to think about it in bigger contexts about the way we use AI and technology. Clay Shirky, who's a new media professor at NYU, refers to this as algorithmic authority. The result is basically a system that lets everybody off the hook for sustaining the ugliest of human biases. When we begin to rely on algorithms and computers, we tend to believe that the machine must be making good decisions and that we don't have the authority to question those decisions. We might say, well, a computer isn't going to act in a racist way, right? But yet, when we look at the case of Niger Parks, or when we look at the way that it falsely links people that it observes in a database to the people that it observes in reality, in real life, and that it gives false identification 30% more of the time, well, it's hard to say what that is if it's not racist, right? There's racism built into the algorithms for a variety of reasons. And we're going to talk about some of why that is. But the case in point is an algorithm is not neutral. A computer system is not neutral. It is enacting a set of biases from the real world based on the data that we've collected about the world, the choices we've made about that data, and then fed to the system. And if we don't think about it this way, then what we surrender is the impulse to think critically about the messages that machines give us, about the images of the world that the machine creates. So being built by engineers miles away from the communities where they're used, looking at decades-old data, and often usually using data that nobody really ever looks at, no human goes in and reviews, we nonetheless ask the machine to make a guess and trust that the guess applies to every situation it might meet. We assume that the machine will be applied to everyone equally, regardless of their gender, race, or disabilities. Companies have designed police patrol scheduling software without ever considering that assigning more patrols to neighborhoods would influence the arrests in those neighborhoods and then result in sending more patrols to these neighborhoods. They've built sentencing software on data without ever looking at whether existing prejudices from decades past might influence the statistics that they use to create that pattern recognition. If you recall this idea of never ask why, only say because, we start to see this again. It came from 1965, but here we are. You don't ask why the data is that way. You only say, we're doing it because the data is this way. And then you end up enacting uncritically some of the biases that are present in data and applying it to situations it doesn't belong to. And when these systems fail, we might ask who's responsible. And we might hear from police departments that it was the engineers, and the engineers say it's the data scientists. The data scientists say it's whoever produced the data in the first place. And ultimately, time and time again, you see errors of this type simply chalked up to being the result of a flawed algorithm. But algorithms don't spontaneously emerge. They're designed by humans, or they're the result of looking at human-assembled data. And if we don't have the proper oversight and the proper instinct to think critically about the technologies we develop, we might end up having vast social consequences. So this mindset that we're safe in this vast sea of data, that we're tiny raindrops that nobody is looking at, obscures the reality that for many people, when the eye turns to look at them, nobody is there to help or clarify or intervene. So we may feel very safe that we are anonymous in the sea of data that's being collected about us, but consider the fact that your data might help to build a system that turns its eye to somebody else who isn't as lucky. This is what I refer to in the title of this talk. Nobody is always watching you. In our effort to reduce really difficult problems without easy answers into step-by-step instructions that a computer can follow, we're bound to get stuff wrong. We're going to lose context of where the data came from and what the relationship of the data we collect is to the reality that was observed somewhere. And we might end up prioritizing people who have a similar background or an assumed background to the people designing the systems. Now, we can do a lot to mitigate this. We can hire more diverse perspectives in engineering so that people from communities that are directly affected can contribute to the design and implementation of these systems. But some folks like Timnit Gebru, formerly responsible for ethics at Google, has long asked the question of whether we need to build these systems at all. If we know that a process has greater negative impacts on one group of people over others, do we need to start automating that? Is it ready to be automated? Will it ever be ready to be automated? Are these things we want to hand off to a machine? Do we need technologies to assist in the massive disproportionate use of the prison system against Black men in the United States or Chinese Uyghurs? Should we invest in making those systems more justice-centered first, and then building algorithms that reflect a working system, a fair system? Technology is not the only way to build better systems. We can shift our priorities. We can look at things from different positions. And that's a strength in diversity. It amplifies the breadth of imagination in a room when we're talking about how we build something. And this isn't to lean into the glorification of pure emotion or candy coat the hard work of design and engineering at the expense of reason. We need logic. We need reason. But a complex world also requires imagination and emotion and subjective human judgment. The danger of emotion has never been that we might use it to guide us towards compassion, right? Emotion isn't meant, we don't fear emotion because we might do something nice, right? We're not trying to cut emotion out because we might care about somebody else. The danger in emotion is that we might convince ourselves that reality conforms to our rawest emotion-driven intuition, right? Emotion might say, of course I'm right. This is the only thing I know. And this is the only thing that makes sense to me. Anyone else who disagrees is wrong, right? Or has an agenda or an axe to grind. But if we look through this lens of emotion and compassion, we know that there are deep human challenges of judgment and morality and justice that you can't reduce to algebraic equations or consistent repeatable rules. We need to abandon the idea that you can simplify hard choices into easy ones. When you simplify hard choices into easy ones, that's the world of Big Brother that Orwell described, where someone holds up 3 fingers and we have to say that there's 2. We know that you can't predict the future. We know that we don't like every movie that Netflix recommends. And yet here we are, deep into the 21st century, believing that handing computer decisions about human freedom and dignity is still a good idea. So I'm encouraging you to be critical, to assume that the incredible achievements you'll see happening in the field of artificial intelligence may not necessarily be a social good just because they're spectacular. We can start looking at our algorithms and machine learning systems with more than the critical detachments of Winston in 1984, where he looks at terrible events and he just reflects on how masterfully they were enacted, right? Rather than admiring what technology has shown us what it can do, let's ask if what it can do is what we want to see. Instead of praising the skills of engineers in squeezing even more capabilities out of the machines that surround us, we might ask if the machines are doing the things we need. I fear that the great risk of artificial intelligence is not that we build a machine that rises up and captures us and traps us, but that we build a machine that we surrender to out of boredom. That our exhaustion at the idea of thinking through ethical and moral complexity means that we're going to hand life and death decisions to a Roomba. I leave it to you to figure out where the truth falls into the mathematics of machines. You, as artists working with data sets, have your own conclusions to draw. And I welcome you to draw the conclusions that you do. I welcome you to choose your own lines, as I have, as many people must, about where you're comfortable sharing your data and where you want to hold your data back. Whether this idea of sharing information about yourself in a vast ocean of information really doesn't matter, or whether dropping your data into this data set that can then be used to build tools that might be used in other ways is something that you want to get involved in or think through, and how you want to think through that. These are all up to you. These are decisions that you get to make as you work with this material and you think through this material. But I just want to say that when we encode the past into an algorithm and ask it to decide the future, we're not creating an objective neutral system. We're creating a system that persecutes according to a set of limited principles that it has mistaken as universally true, and that the past will end up being repeated in the present into the future. If we want to change that future, we need to think about what it is in the past that needs to be changed and how to change that and how to tell the system to do that. So on that note, my parting words are that Orwell gave us a tragedy, and it's hard to go to an upbeat note to finish this lecture, but I want to find a useful reminder. Orwell writes, "The terrible thing that the party had done was to persuade you that mere impulses, mere feelings were of no account, while at the same time robbing you of all power over the material world. Only 2 generations ago, what mattered were relationships, not loyalty to a party or a country or an idea." Orwell is talking about political ideology, but I want to encourage you to think about this in the sense of the relationships that you have with the world and the relationships that algorithms and AI has with the world, and how those things are aligned or how they're not aligned, and to approach things from this perspective of your relationships first. If automated surveillance systems are leading to false accusations against your neighbors, let's ask if you need them. Okay, if Facebook is making us argue with each other, let's ask whether we need Facebook mediating those conversations. I can't really turn to Norbert Wiener either for optimism, though he did leave us with a powerful push to ask hard questions. He writes, "It is relatively easy to promote good and to fight evil when good and evil are arranged against each other in 2 clear lines, and when those on the other side are our unquestioned enemies, and those on our side are our trusted allies. What, however, if we ask each time and in every situation, where is the friend and where is the enemy? When we have to put the decision in the hands of an inexorable magic or an inexorable machine, how might we ask the right questions in advance without fully understanding the operations of the processes by which they will be answered? And I can also turn to Alphaville, Godard's reimagining of Orwell's 1984, set on a distant planet, where Godard's Alpha 60, the central computer that runs the city of Alphaville, is defeated with just a few lines of poetry. Godard hits on something here, that the human mind can be unpredictable, and that unpredictability can be what drives us to produce beauty and art and imagination. It suggests that human behavior can change, that people can grow, learn, and transform. And it suggests that making something new is more than just recombining elements of things that have come before. And this is another question that's very relevant to us as artists working with artificial intelligence and data. We decide the ends to which these systems are aimed, so let's prioritize relationships and communities and well-being first. And let's think about some harder questions about what this technology is promising and what it does. Let's think about where it came from, its relationships to things like flawed surveillance systems. And let's give space to humanity's capacity to become better, to recognize the limits of what we can know and how we know it, and to build a future open to all the mysteries that we haven't answered yet. And let's think about how we can think about our art and the art we make through these sets of questions. So thanks for listening. I hope you learned something today, or at least thought through something. I welcome your feedback. I welcome your criticism. The idea of this talk is merely to put some ideas out there for you to contemplate and make your own decisions about the ways that you want to use AI, the approach that you take to AI, and the way that you frame AI-generated data in general, including that of AI images. Thanks for listening.